So here's another example. This one, we have 3 equations and 3 variables, but elimination is so nice it allows us to do this. Show you what I mean. If we could find a way to eliminate one of these variables in 2 different ways, we would be able to, we'd have 2 equations and 2 variables which we could get. A picture of what's going on here is this is now, instead of a line on a graph, this is a plane, a flat surface through a 3-dimensional space. And 3 of them could intersect at one point. So that's what we're going to try to find here. Now, if you look at these, we look and see, oh, if we just added these 2, the y's would go away. And if we added these 2, the y's would go away. So I'm going to introduce some notation here. I'm going to put an arrow like this and say these 2 are being added together and making a new equation over here that I'm going to write. X plus x, that's a 2x. Y and negative y, gone. That's what we wanted to have happen. And negative 2z minus z, that's a negative 3z equals 3. Notice we now have an equation where y is gone. So we could pick any other way to get rid of a y if we wanted to. We could just add these 2 together, but for the sake of this notation, I'm going to show you another way we're going to do it. But you could just do that. I'm going to take these 2 and I'm going to times this guy by a negative 1. You could have just done these 2 and had another equation. That's okay. So negative x, because we times this whole thing by a negative 1, plus this guy, negative x plus 3x gives us a 2x. Negative y plus y is gone. That's what we wanted to do. And positive 2z, that's a plus 4z equals negative 3 plus 13 is 10. I'm going to change colors here one more time. And here we're back to where we were with the problems before. We have 2 equations and 2 variables. We need to get rid of one of them by elimination. Wouldn't it be nice if this were a negative 2x, or if that were a negative 2x? Let's make that one negative. So I'm going to take these 2 equations. I'm going to times this top one by a negative 1. We could get rid of these. We could have times this guy by a 4 and this guy by a 3 to make them both 12s, but this is a little bit easier. Negative 2 plus 2 is gone, and we have positive 3z and 4z is 7z. And here we get equals 7. That means z equals 1. Now, the reason I like this notation is the problem was huge, got a little bit smaller, got smallest. Now we have one answer. Now we go back here and say, okay, let's find x. 2x plus 4z times 1 equals 10. Now we have just one equation to solve. 2x equals 6, x equals 3. Now we have z and we have x. We move back one more step, and let's get y. So we could stick this into any one of them that we want. Let's choose the bottom one. So let's put a z right there. Let's put the x right there. So we have 3 times 3 is 9, plus y, plus 2 times z, which is 1, equals 13. 9 plus 2 is 11. So if we subtract 11 from both sides, we have y equals 2. That means our answer is x is 3, y is 2, and z is 1. One last thing. There are some odd duck answers you may get. Sometimes systems of equations, I'll give you an example really quick here, but sometimes they'll give you some answers and you're like, what is going on? You don't get an x equals this or a y equals this. If I had something like 2x plus y equals 9 and 4x plus 2y equals 18, you may think, wait a minute, all you did was times this guy by 2. I thought you said that gave us the same line. Yeah, if you were to try to eliminate something, you would get a statement like this. 0 equals 0. Now way back in the last unit where we did equations, whenever we got 0 equals 0, the answer was like all numbers. Well, what happens is we are trying to find where these two lines cross. And we got the answer 0 equals 0. Well, how often is 0 equal to 0? Always. These lines are always crossing, which for this, we don't have all numbers as a solution. We have this set of numbers, which is an infinite, huge, big set of numbers that works. So we just write down infinite number of solutions. However, similar to what we did before, if you should ever get something like 0 equals 7, or 0 equals 1, 0 equals 13, negative 26 equals 13,000, these are just false statements. These never happen, which means that the intersection of both of these lines, or all three of these at the same time, will never happen. Or in other words, just like we did in the previous unit, there will be no solution. So those are the two kind of exceptional cases where you may end up with 0 equals 0 or some other always true statement, in which case you have an infinite number of solutions. And 0 equals 7 will give you no solution whatsoever.